Um, how is it going? How's it hanging, everyone? So let's get started today with our warm-up for today. Oh, also, by the way, there is a graphic organizer that goes along with today's lesson. So please make a copy of it and fill it out. This is pretty important because there's a lot of graphs on there that you can see. So there's a space for you to fill the warm-up. But for the warm-up itself, let me read the question. So a Toyota Prius, Priuses are great cars, by the way. I'm not sponsored by them, but I would gladly take a free Prius, of course. So a Toyota Prius can go 0 to 60 miles per hour, which is roughly 26 meters per second, in 10.6 seconds. A Tesla Model S can go from 0 to 60 in about 2 seconds. So which car has a faster acceleration? We have 4 choices for you today. We have choice number 1, which is the Toyota Prius. We have choice number 2, which is the Tesla Model S. We have choice number 3, which is that they have the same acceleration because they are speeding up to the same speed. And then we have the last choice, which is neither of them are accelerating. So out of these 4 choices, pick the one that you feel fits the best. You feel like best answers the question, which car has a faster acceleration. By the way, there is a graphic organizer that goes with today's lesson, so make a copy of it and please fill it out as we go along. There's a lot of graphs there that are very helpful to see. But yes, please do answer the warm-up question. We're currently at 11 out of 13 people, which is pretty good. Let's see if we can hit that 100%. Which car has the faster acceleration, the Toyota Prius or a Tesla Model S? We are currently at 14 out of 19 people have answered the poll. Let's try to get those last, right, 15 out of 9, let's try to hit the last 4 people. So for those of you just joining us, there is a graphic organizer that goes through today's lesson. It's on Canvas, but I'm gonna link it again in the chat here. So we are sitting at 15 out of 22. So for those of you just joining us, there's a graphic organizer that goes along with today's lesson. But please also answer the warm-up question. So a Toyota Prius can go 0 to 60 miles an hour, which is roughly 26 meters per second, in 10.6 seconds. A Tesla Model S can go 0 to 60 miles per hour in 2 seconds. Which car has a faster acceleration? We have 4 choices for you, which is the first choice is that Prius accelerates faster. The second choice is the Model S accelerates faster. The third choice is that they have the same acceleration because they're speeding up to the same speed. And then we have the last choice, which is that neither of them are accelerating at all. Let's take another 50 seconds or so. We're currently at 20 out of 23. We are almost at 100%. We just need 3 more people to respond. Take about 40 seconds or so. We're at 21 out of 23. If you're one of the last 2 people, please answer the poll. Every vote matters. We are at 22 out of 23. We are really close to hitting that 100%. We have 20 seconds left for the last person to answer the poll, and then we will talk about which one has the faster acceleration. Oh, we hit 100%. I feel like usually I'm supposed to do something, but I'm like really dead. I don't know. I'm really, yeah. So one day I'll figure out a way to how to celebrate. Anyways, okay, we hit 100% for a split second. Okay, so which car has the faster acceleration? So indeed, the Model S does have a faster acceleration. But what I want you to do now is I want you to try to actually create an explanation for why the Model S has a faster acceleration. So it doesn't. I'm telling you right now, the Model S has a faster acceleration. That may or may not have been what you initially believed, which is okay. That's why we're here to learn. So regardless of whether or not you initially believed that Model S has a faster acceleration, I want you to try to create an explanation for why it does have a faster acceleration. So even if you disagreed with the initial idea, I want you to try to come up with an explanation for why the Model S has a faster acceleration. So in your group, try to create an explanation. Make sure you include the two words velocity and acceleration. So when we come back, we're gonna have everyone type it out and then we'll have everyone share it, but not yet. So I'm gonna put you in your groups now. And then the next few minutes or so, I want you to try to come up with an explanation for why the Model S has a faster acceleration than the Prius, and try to use the two words velocity and acceleration. We want to practice using our vocabulary in this class. So we'll take a few minutes and see if we can come up with some good explanations for why the Prius is slower acceleration than the Model S. Go, 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 go. So I heard some good ideas so far. So what I want you to do now is I want you to type in your explanations for why the Model S has a better acceleration than the Prius, but don't hit enter yet. We want to give everyone a chance to type it in. So start it ready. We'll take, let's see, how long do we want to take? Let's take a minute or so. So type in your responses, type in why your explanation for why the Model S has a faster acceleration than the Prius, but don't hit enter yet. And then when I say go, 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 get ready to go, 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 and hit enter. And we'll see what everyone has to say. So let's take a minute or so. Type in why you think the Model S has a faster acceleration than the Prius. In other words, why should Mr. Hu spend all of his salary on one car instead of, I don't know, food or rent or, I don't know, other things, taxes. So let's take another 40 seconds or so, get your explanations ready for why the Model S has a faster acceleration than the Prius. And in about 30 seconds or so, I'll say go. If you jump the gun and you go too early, you will lose 1,000 points in this class. Okay. Let's go in 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Go. Go. Let's see how many we can get. We got a lot. We actually have a lot. Let's get some more. Let's get some more. I mean, you're still typing in. Please do type it in as you can. Not everyone types fast. We got a bunch of these. I'm gonna start reading through these. But if you haven't typed one in, please do so. Let's try to get as many ideas as we can. Okay, so let's see. Okay, the Model S has a faster acceleration because it depends on how fast you get to a certain velocity, not if you do. Acceleration is equal to velocity over time, meaning if you have to consider the amount of seconds or minutes in which you reach that specific velocity, and that determines the faster acceleration. That is a really, really, really cool explanation of it. And I like how you talked about how it's not if you get to a velocity, but how fast you get there. So that's really good. Tesla has a faster acceleration because it is able to have the high velocity in less amount of time, which allows it to have a faster acceleration. It is able to increase velocity faster. That's a good idea. I like how you talk about increasing velocity faster. The equation for velocity is changing its velocity over the time, and the Tesla Model S was able to achieve the same velocity in less time. Therefore, the Model S has a great acceleration. So I like how you talked about the equation, and you talked about how include a little bit of math there. That's a really good idea. The Model S has a faster acceleration because it had a shorter time to get to a certain velocity than the Prius. Great, succinct way of summing it up. Exactly. Model S has a fast acceleration because the speed at which they reached the maximum velocity was a shorter amount of time for the Model S than the Prius. Even though they might reach the same velocity, the Model S reaches it first. Exactly. It's about who reaches it first. That's why Model S is faster because the speed at which it reaches maximum velocity is a shorter time than the Prius, letting it have a faster acceleration. The Tesla accelerated faster and reached 60 miles an hour in a shorter time. Yes, it's a lot of it. It's an idea of getting to a certain velocity faster. So we heard a lot about that, and I like that. The Tesla Model S is faster because it's a Tesla versus a Prius. Lol. That's a little hurtful. I think Priuses are great cars. And one day what's going to happen is there's going to be an insanely fast Prius, and it's just going to make you look really bad. So don't insult the Prius because one day it'll be the fastest car in the world. The Model no cap. I'm serious. Priuses they're beasts of cars. The Model S has a faster acceleration because it is able to reach a faster velocity in a shorter amount of time. Thus, the rate of change for speed over time is greater for the Model S, making it the quicker vehicle. Yes, 100%. So a lot of this idea of better acceleration comes down to this idea of getting to a velocity faster than someone else. So that is, I like what I've heard so far. Those are some really good ideas. So what we are going to do today is we are going to continue analyzing the concept of acceleration. What we're going to do is we're going to look at acceleration in terms of graphically. We're going to try to really understand what it means for a car to who dollar you capping. That's I never cap. I don't no cap here. I never lie. So Tesla equals fast. Teslas are fast. I never said anything about Teslas being slow, but Priuses are great cars. And you can fight me if I'm wrong.
Today we're going to keep talking about acceleration. We're going to look at it graphically. We're going to do a little bit of math here, and we are going to see if we can really try to fully understand what it means for something to accelerate, what it means for something to go faster. So that's our goal today. Make sure you open up your graphic organizers. The next few, we'll be looking at a lot of graphs, and the graphs are all on the graphic organizer. So please do so if you can. Tesla goes fast, Prius goes slow. I never said that was incorrect. I'm just saying that Priuses are great cars, and one day Priuses will be the fastest cars in the world. Okay, so I don't even know what that emoji is. Oh, that's a baseball cap. Oh, okay. No. Oh my God. Oh my gosh. Okay. So what we need to do is we're gonna first look at a graph here of a Model S's acceleration. And what I have here is I plotted the velocity of the Model S on the y-axis, and I have the time on the x-axis. And so what we want to do is we want to answer these 5 questions. What I first want you to do is I first want you to identify what the Model S's velocity is at 0 seconds. I want you to identify what the velocity is at 2 seconds. I want you to figure out what the velocity is, what is happening to the velocity over time. I want you to analyze how much does the velocity change every second. And then I want you to predict what the Model S's velocity would be at 3 seconds. So there are 5 questions here. What I'm going to do is I'm going to put you in your breakout groups, and you'll get a chance to work with your groups to try to figure this out. We'll probably take about 5 minutes or so, maybe a little less, maybe a little bit more. So within your groups, try to answer these questions. These graphs are all on the graphic organizer. So when I put your data earns, you won't be able to see the slide, but it'll still be in the graphic organizer. So within your groups, try to answer these 5 questions and see if you can use your graphical analysis skills to figure these questions out. I'm opening rooms now, and go. Go, 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 go. Go, 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 go. Go, 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 go. Go, go, go. So let's talk about the last graph here. Okay, so first off, what we want to do is we want to figure out what the initial velocity is. What is, for the first question, what is my velocity at 0 seconds? Well, at 0 seconds, what we want is we basically want to figure out what our y value is when our time value is 0. So as we're looking down the graph here, our time value is 0 here, and our y value at this point is 0. The point is 0, 0. So our initial velocity is 0, which means that we're not moving at this point. So at 0 seconds, our initial velocity is 0. What is my velocity at 2 seconds? What I'm doing something similar. I'm going to look at the graph here, and I'm looking at where my x value is 2. My x value is 2 right here. So if I look up and see what my y value is, I see that my y value is 2, 26. So my y value is indeed 26. So at 2 seconds, we're moving 26 meters per second. So what is happening to my velocity over time? So my velocity over time is increasing, right? As you can see, there's a positive slope. Our velocity went from 0 to 13 to 26. So every second, our velocity is increasing. And so this means that we're getting faster, right? So initially, we're moving, and we're moving faster, and we're getting faster than that. So our velocity is just getting faster over time. How much is my velocity changing every second? Well, initially, my velocity was 0. After 1 second, my velocity was 13. After 2 seconds, my velocity is 26. So every second, I can see that my velocity changed by 13 meters per second. Now, the last one is we've got to predict what our Model S's velocity would be at 3 seconds. Well, if it goes up 13 in 1 second, it goes up another 13 in a second. So in a third second, we would go up another 13. So we would expect our velocity to be 39 meters per second, right? So 13 plus 13 plus 13. This just gives us a final kick velocity of 39 meters per second. So that's not too bad. Pretty standard graph. What we're going to do now is we're going to look at another graph here that is going to be a little bit harder. What we have now is we have a graph that, again, is a velocity versus time graph here. But this time, as you can tell, the shape is a little bit different, the numbers are a little bit different, and there's a little bit more wonky stuff going on here. So once again, I want you to answer a few questions here. I want you to figure out what the velocity is at 3 specific point in time. Now for question 3, question 3 asks, what is the Model S doing in the first 4 seconds? So what do I mean by this? I mean is if you were sitting in the car, what is the car doing? Right? What is the car doing in the first 4 seconds? For question 5 is the same thing, right? For the last 4 seconds, if you're sitting in the car, what would the car be doing? And then I want you to answer how much is the velocity changing every second? And then the last question here is I want you to predict what the velocity would be at 20 seconds. So yeah, we got 6, 7 questions for you to answer. I'll once again put you in your groups here and try to answer them as well in your graphic organizers. So we'll take another 5 minutes or so to work through this one. And then we'll come back and I'll go over it again. So get ready, go.
All right, it's pizza time. Okay, so let's go over the thing, Barb. Okay, so what is the velocity at 0 seconds? So to start off with, trying to figure out the velocity at 0 seconds, what we want to do is we want to look at the graph here and we want to be like, okay, where is my velocity at 0 seconds? So at 0 seconds, it's here. I go up to my y value. So at 0 seconds, my velocity should be 2 meters per second. If I want to do the same thing at 4 seconds, what I'm going to do is I'm going to look at the x-axis, look where the 4 is, and I'm trying to find what my y value is. It's right here. So 0, 2, and this one is 4, 0. So we know that my velocity at 4 seconds should be 0. Now, which means that we initially started moving because we had a positive velocity. And at 4 seconds, our velocity is 0, which means we're not moving anymore. We're stopped. So to go from moving forward to stopping, what we have to do is we have to be braking essentially. So in the first 4 seconds, I'm braking. I'm going forward and then I'm hitting the brakes. And after 4 seconds, I'm fully stopped. And this is because my velocity was initially 2 and I'm slowing down, I'm slowing down, I'm slowing down. And after 4 seconds, my velocity hits 0 and bam, I'm stopped. So what is my velocity at 8 seconds? Where I'm going to do something similar. I'm going to look at where the x-axis is. Here's 8. What is my y value? It's down here. So it's 8, -2. So my velocity at 8 seconds is -2. So what is my Model S doing in the last 4 seconds? Well, let's think about this. I'm slowing down, I'm slowing down, I'm slowing down, I'm slowing down, and then I'm stopped here. So is it possible to keep slowing down after you stopped? Not really, because when you keep braking and keep braking and keep braking and you stop, eventually what happens is that instead of slowing down more, you actually start moving backwards. So basically what happens is you're moving forward, moving forward, moving forward, and you're slowing down and you stop. And then what happens, you start moving backwards. So only when your velocity is 0 are you stopped. Then what happens is we start moving in the negative direction. That's why the velocity is negative, because it tells us that we are moving in the negative direction. So right here, this section, we're moving in the negative direction. We're moving in the negative direction. And if you look at it, we're actually speeding up because our velocity is getting, like, in a sense, we're actually getting faster. We are moving in the negative direction, but how much distance we're covering every second is actually getting faster. So in this case, in the last 4 seconds, I'm actually speeding up, but in the negative direction. So this is really weird. We're slowing down here because our velocity is decreasing. And somehow our velocity is decreasing even more, but we're actually speeding up at this point. This is because we switched directions. I want you to think about it like this way, right? Imagine you're driving and you hit the brakes, and eventually you stop, right? Well, after you stopped, you switch your car into reverse, and then you hit the gas again. So that's what essentially is going on here. Right here, you stopped, and then you switched your car into reverse, and then you started speeding up again. So now here, at 8 seconds, you're actually moving faster than when you're moving at 4 seconds. So that is kind of tricky because we normally, when you think of velocity decreasing, you usually think of that as slowing down. But I want you to realize that sometimes if your velocity is decreasing, you can also be speeding up. It just depends on which direction you're moving at. So what I really want you to start looking at it, and I want you to start thinking about it, which direction am I moving at? So therefore, am I speeding up or am I actually slowing down? So in this case, we're actually speeding up. How much is my velocity changing every second? Well, let's do a little bit of a rise over run. So what this is basically asking is, this is basically asking for a slope, right? When I'm asking for how much something changes every second, this is basically asking for the slope of the graph. So if you want to find the slope of the graph, what we need is we need the rise over run. So what I'm going to use the 2 points, 0, 2, and 4, 0. So between 0, 2, and 4, 0, my rise is -2. So I initially started at 2, and then I went down to 0. So my rise is actually -2, right? And so it's not +2 because I didn't go higher. I actually went lower. So my rise is -2 and my run is 4 seconds. So my slope would be -2 over 4. And so this would just be -1/2. So every second, my velocity is decreasing by -1/2 meters per second.
So now, last but not least, what would the velocity be at 20 seconds? This is kind of the hard one. So there are a few ways of doing this. Here is one way you can think about it. One way you can think about it is that every 4 seconds, your velocity decreases by -2. So after 8 seconds, it decreases by -4, which means that at 20 seconds, it should decrease by -10, right? So you're basically multiplying 4 by 5 and -2 by 5. So after 10 seconds, after 20 seconds, it should decrease by -10. Another way you can think about this is that every second I'm decreasing by -1/2. So if I multiply this by 20 seconds, I'll just get that, I'll have a total decrease of -10, -20 meters per second. So it's really just looking, you're basically just looking at patterns here, right? You're looking at patterns. You're trying to figure out how much is it decreasing every second, and therefore you can sort of make a prediction for how much it should decrease after 20 seconds. So after 20 seconds, we know that it should decrease by about 10 meters per second. Now that's not our answer though, because we know that it decreased by 10 meters per second, but that's not what our final velocity is, because we actually started at 2 meters per second. So we started at 2, then we decreased by -10, our final answer should actually be -8. We started at 2, and over the course of 20 seconds, our velocity decreased by 10, or in other words, we added -10. So when we add 2 to -10, we find that our final velocity is actually -8 meters per second. So that is going to be a huge part of this unit. It's really going to be able to try to make predictions about what's happening in the future based on patterns that we're looking at. So this is where we sort of have to play detective here, where we sort of have to, look at the data and try to figure out some patterns of what's going on. So that is pretty much the gist of this particular graph. Does anyone have any questions about this? Okay. So let's go on to another slide here. Okay, so what I want you to do now is I want you to look at this graph here, and then I want you to try to essentially explain what's going on with like a very short story, like a sentence or so. So there's a graph here, looks, somewhat similar, maybe a little bit different than we did. And I want you to try to explain with a story, what's going on. So like a very short sentence, like what's going on, what's happening here, who's driving, who's walking, what are they doing, and try to explain this graph. Here are some things that you may want to think about that can help you guide you as you're looking at this. So first off, what is happening to the velocity in the first second? So what's happening to the velocity? What does that mean? What am I doing in the first second? Then I want you to think about what's happening in the second second. So between 1 and 2 seconds. What is my velocity doing? What's happening? What's going on? And then you might also want to think about how much is the velocity changing every second. So these are some 3 questions that will help you sort of figure out what's going on. And you're going to write a very quick story, like 1 sentence or so, just that sort of shows what's going on. So I'm going to put you in your groups right about now. Okay, dokie. So what I'm going to do is I'm going to quickly share a quick story that sorry, this is too far ahead. Okay, so what I'm going to do is I'm going to quickly share a story that I think probably sums up this graph the most. This graph is kind of wonky. Basically, what happens is that initially you are moving in the negative direction. You're actually slowing down. After 1 second, you're actually stopped. And then you start speeding up again in the positive direction. So if you don't, that doesn't make any sense to you, here's how I want you to think about it. Basically, initially I was moving in the negative direction. So imagine if you were driving and you're in a parking spot and you're backing out of the parking spot. So you're moving in the negative direction. So your velocity is going to be negative. Now, as you're almost backed out of the parking spot, you start slowing down because you don't need to back up any further. So you start pressing the brakes. Okay, so basically, poor Reza here, was backing out of the parking lot, right? You're back in the parking lot, and then he hit a squirrel. So when he hits a squirrel, he slows down and he brakes. And then as he got scared, he drove off on the freeway. So basically, you're backing up, you're slowing down, you brake, and then you start speeding up again in the forward direction. Poor Reza, he got scared. Dead squirrels are very unfortunate, but that's basically what happens for this story. That's why this graph can be really wonky. So it's good to understand visually what it means. We're going to do one last quick thing. I want you to quickly solve this problem, well, as much as you can. So in this problem here, if an object is moving at a velocity of 12 meters per second, and it decelerates at a rate of 4 meters per second every second, what would its velocity be at 10 seconds? So if an object is moving at a velocity of 12 meters per second, and it decelerates at a rate of 4 meters per second every second, what would its velocity be at 10 seconds? Well, this question is asking for your velocity after 10 seconds. So how fast are you moving after 10 seconds? So we're not looking for a time, we're looking for a velocity. To give y'all a hint as you're looking through this, so what the question means by decelerates at a rate of 4 meters per second is that every second my velocity is decreasing by 4 meters per second. So what this means is that at 0 seconds, my velocity is 12. At 1 second, my velocity would be 8. What we want to do is we want to figure out what is my velocity when my velocity went at 10 seconds. So that's what this part means when it says decelerates at a rate of 4 meters per second every second. So our velocity decreases by -4 every second. So how much would what would our velocity be at 10 seconds?
So to work through this, what you want to do is, I think it's a helpful thing is to figure out how much does my velocity change in the total of 10 seconds. Well, if my velocity decreases by -4 meters per second every second, that means in 10 seconds, if I multiply this by 10, what I know is that in 10 seconds, my velocity actually decreases by a total of -40 meters per second. So this is how much my velocity changes in total in 40 seconds. So if I take my initial velocity, which is 12, and then I change it by -40, what I get is that my final velocity should be -28 meters per second. So what I did was I figured out how much my velocity changes in 10 seconds. I found that it changes by -40. And then I took my initial velocity and then I changed it. And then I get my final velocity is indeed -28 meters per second. So hopefully that sort of made sense to you, or at least part of it made sense to you. So we got through about halfway in the graphic organizer. So we will continue the lesson on Friday. So obviously you're not gonna finish that today. So you don't have any homework. That's pretty much it. And I will see y'all on Friday.
Thank you.
Bye.
Thank you.
Thank you. Thank you.
Bye-bye.